Hello everyone and welcome back to another episode of The Hidden Quantum Champions. Today we are looking at a company called Riverlane, and with that let's hop onto their website. So here it says, the error correction stack that unlocks useful quantum computing. Let me reload the page because there's this cool animation also running here on the side, just so you see that one. It looks really cool. So what does it say here? The Quantum Error Correction Report 2024 discovered the most comprehensive review of quantum error correction, QEC, the defining challenge for today's quantum computers. Packed with cutting-edge research, analysis, and insights from top industry experts, this three-part report breaks down the complexities of quantum error correction in an accessible way. We might look into that later on, maybe in a separate video. But maybe just to give some context, because I also got the feedback from some people that sometimes we are just starting right into it with all the wording. So quantum error correction, what is it? Why is it needed? So today's qubits, they all have some errors. That's partially because of the disturbance that is coming from the outside, because a qubit is based on a quantum two-level system, which by definition is the smallest energy separation possible, right? Because it's a quantum system. And that means if there's some kind of disturbance, like even a small fluctuation or anything, that can already impact your quantum system. So for that reason, there's some outside disturbance, and there's also some, let's say, errors in how you're doing the manipulation of the qubits, right? Because if you put in a specific signal, there's always some error going along with it. Nothing is perfect, right? So you might not turn the qubit by exactly not flip it exactly from, for example, 1 to 0, but you might flip it a little bit off of that, so that in the end it will not make a difference, because when you measure it anyways collapses into this 0 state. But if you do a lot of operations, this error will accumulate after a while, and that can also cause some error. So we have the intrinsic error, and there's some disturbing errors. Now, why do we now need this error correction, and why is it such a complicated topic? So it is so complicated because in the world of quantum, you want to be able to entangle all of these qubits. So suddenly the error that you're doing on one specific qubit is now spreading across your whole network of qubits, because they're all entangled with each other. So you're smearing out that error across your whole chip, across the whole system. Maybe it's even multiple chips, right? So across the whole system. And that makes it really, really hard to correct for those errors, because in the quantum world, you cannot just copy information. There's a non-cloning theorem. So you can basically not just say, I create one qubit and another one, and I make both of them one, or I copy just the information from the one, and then when it kind of flips and does something, I just copy it again, and then I basically can create like a checksum or something. That works in classical systems. That's like how you can do data storage and how you can, correct for those errors, but it doesn't work in the world of quantum. So that's why these error correction schemes, they can become quite complex. So there's like surface code, which depends on the geometry of how you put the qubits on your chip layout, for example. And it becomes quite complex to actually create these error correction schemes. So it's a science in itself. And that's why there's companies like Riverlane, I guess, that are experts in quantum error correction and that basically help you with your hardware platform, for example, to get this up and running. And this error correction is very important, because if you can do that, you can basically, not only mitigate, you can remove all of these errors, you can correct them, and thereby you can, at least in theory, run algorithms that are much, much longer, much more operations after each other, and then also many more qubits than what you could do if you would just use the physical qubits. It also comes at some disadvantage. So the caveat is that for one error-corrected qubit, you need multiple physical qubits. So if you, for example, have 100 physical qubits, you might at the end only end up with, 20 error-corrected qubits, because of the way that you are implementing this error correction code. So that just as a side note. Now let's hop back onto the website of Riverlane. So we've seen this report here. Then when we scroll further down, there are some updates. I'm producing this video mid of September. We see there's some news here from beginning of September, which says Riverlane to deploy quantum error correction at Oak Ridge National Lab. So that's like the latest one. So the section is pretty much up to date. We also see OQC here as one of the major quantum computing suppliers nowadays. So they also seem to work together here. Okay, let's see further down. There's something here about error correction. Quantum error correction is the industry's defining challenge. Quantum computing will be one of this century's most transformative technologies, broadening the scope of what is computationally possible. World-changing use cases will require millions of reliable quantum operations or more. Today's quantum computers are prone to errors, making about 1 error per 1,000 operations. This error rate needs to reduce by millions of times before we can reach capabilities which surpass the supercomputing threshold. This target is far beyond what can be achieved with hardware improvements alone. Real-time decoding is required to identify and correct a vast number of errors at speed. Now here we see something that looks like a product. So it's like a green box, looks also a bit like the shape of a rack. What does it say? Building the quantum error correction stack to unlock useful quantum computing. Riverlane is building the quantum error correction stack. Delta Flow to reduce logical error rates, enable quantum computers to scale up and tackle problems that are intractable using any classical supercomputer. Delta Flow has all the functionalities needed to perform reliable quantum operations at scale, including real-time error decoding, logical orchestration, and a universal control interface. Our Delta Flow roadmap will reach a mega QOP, a million real-time quantum operations. This is the critical milestone when quantum computers reach sufficient scale to execute the first error-corrected quantum applications. So it looks like what we are seeing here is a dedicated compute unit that is like optimized to perform the readouts and the operations that are required in order to get error correction mapped onto a physical piece of hardware, onto a physical quantum computer system. We also see there's some research here. Then we see the partners, so the companies that they are working together with. We see OQC that we've seen before. There's also Alice and Bob, IQM, Pascal, Qblocks, Rigetti, QEra. There's also Xanadu, Zurich Instruments, Rolls-Royce as maybe something that is not immediately to be connected with quantum computing as a company, and many others. Partner with us. We are now at the point where quantum computers cannot move forward without error correction. If you'd like to partner with us to accelerate the quantum error correction solutions or have any questions, get in touch. And then you can get in touch here and you can also join the team. Okay, with that, we've seen, let's say, the starting part of the website. We are back to the cool animation. Let's quickly look what else we can find here. So there's this part here, the quantum error correction stack with the Delta Flow 2. That's the product that we've seen before. There's the Get Quantum Error Correction Ready, the QEC Explorer, and the QEC-I. There's some research, a newsroom, who we are, so about the company working here and the jobs. Let's first start here at the quantum error correction stack. It starts again with a very cool animation. So we can see here some, I guess, chip architectures that are doing probably the dedicated error correction on this Riverlane chip. So let's see what it says here. Delta Flow, the quantum error correction stack, unlocking useful quantum computing. Delta Flow helps quantum computers accelerate their path to performance beyond the superconducting threshold. Today, the world's best quantum computers can perform at most a few thousand reliable quantum operations before failure due to mounting data errors. This must scale to millions of quantum operations and ultimately trillions for quantum computers to fulfill their vast potential. Riverlane's quantum error correction stack delta flow will unlock this opportunity. Delta flow is a comprehensive quantum error correction solution on a rapid path to utility scale. It includes qubit data readout, decoding, logical operations, and orchestration. So here that's, I think, the important part, right? So it includes the readout of the qubits. So there's some readout electronics in there. The decoding, so basically moving the signals from the readout, so the physical, like the voltage signal, into, I guess, the actual quantum information, so 1 or 0. The logical operations, so basically probably telling the system like what it has to do with the qubits, and then also the orchestration, as in like if you have multiple qubits doing that for the whole system at the same time. Or orchestrate like which is an ancilla qubit, so which is being used to help to read out the errors, and which is like the actual information qubit that is carrying the quantum information to be calculated. Our delta flow roadmap will reach 1 mega quantum operation by 2026, so basically next year. This is the critical milestone when quantum computers reach sufficient scale to execute the first error-corrected quantum applications. And we will check out the roadmap in a second. Now we see here again the product. Next step towards mega quantum operation computing, delta flow 2. Delta flow 2 performs real-time error correction on up to 250 physical qubits with Riverlane's high accuracy proprietary local clustering decoder LCD. So here we already see, so they can run on 250 physical qubits, which will then be translated into less error-corrected qubits. And there's also this proprietary local clustering decoder, which I think is the way that, or basically it is more or less I would guess it's more or less the algorithm that is being used for quantum error correction. There's also a second picture here. And then if we scroll down, how delta flow works. Delta flow turns unstable physical qubits into error-free logical qubits. It has 3 main components working in a continuous cycle to process petabytes of data. First, the world's most powerful decoder. This identifies the error in this data and sends corrective instructions. Then the quantum error correction interface. This processes the qubit readout data from any quantum computer's control system. And then the orchestration layer. This coordinates and synchronizes the complex activities in real time. So we first have the decoder, which identifies the error in the data and sends the corrective instructions to basically the electronics that is then performing the operations of the qubits. Then we have the quantum error correction interface, processes the qubit readout data from any quantum computer's control. So this is basically on the readout side of things. And then on top of that, there's the coordination by the orchestration layer. Okay, so then there's also some more information here on the decoder. The world's most powerful quantum error correction decoder sits at the core of delta flow. It optimally balances speed, accuracy, and resource requirements. The decoder gets broken up into many smaller sections. The data from the logical qubits is spread out across the sections and is processed in parallel to keep up with the huge number of qubit errors. Find out more about our quantum error decoding expertise. Okay, and then there's the roadmap also here. Let's quickly open that one. So on the Riverlane's roadmap, there was first of all the delta flow 1 product, which is already up and out. It can correct for up to 1000 quantum operations. It has fast decoding, solving the backlog problem, and product features include stability and memory, first megahertz decoder, automated data flow, bespoke interfacing. Now we are at the delta flow 2. That's the product that we've seen before. So streaming high fidelity memory, keeping the qubits alive forever. That's a very interesting, very important statement also. So if error correction works, it means that technically your qubit should not accumulate any error anymore, right? So it should be alive forever. It should not start to decohere for some reason and need to be reinitialized to a known state at some point, which is what currently is being done. Then you have the quantum memory, so streaming real-time decoding, leakage-aware decoding, and first universal interfacing. Now with the Deltaflow 3, which I guess is going to be the next product then, it's going to be streaming, it's going to have 100,000 quantum operations, and it says streaming logic, enabling perpetual operations, quantum gates, fast logic by lattice surgery, fast logic by transversal gates, high error suppression rates, and first logical orchestration. And then finally on the roadmap here we see the Deltaflow Mega, which will have 1 million quantum operations, so 1 mega quantum operation, right? And it says logic at scale, first fully error-corrected quantum applications, universal gate set, universal surface code computation, dynamic large-scale orchestration, and low overhead real-time decoding, supporting the LDPC codes. That's the codes that we saw before, the proprietary algorithms, I think. Then there's also this part here on the Deltaflow 2. Here we see the whole layer stack and where basically the product sits. So you have the physical qubit hardware like the chips and the connections. You have the control system which interfaces with the qubits. So basically creating the for example microwave pulses, as it says here, in the gates. So that's like all the physical layer, and then kicks in the Deltaflow. So that's very similar to what we've seen before, right? There's this lower layer here which says data processing and routing, management and routing of syndrome data. Then there's the decoding layer, error decoding and feed forward, and then the orchestration layer on top, which does hardware-aware compilation and processing, decoders coordination. And then on top of that you would have your programming framework, like for example your Qiskit or your PennyLane, whatever. And then on top of that you would build your quantum algorithms and applications, like, I don't know, your pharmaceutical application, your material research, your financial application, whatever. And then we see here the product again with the features that we've been discussing previously, and there's also some data sheet available here. Again, we see some partnerships of companies that are working together with Riverlane. Amongst them, throughout the whole stack, you see companies that are more on the control side of things, on these levels that are very close to the quantum hardware down here, like for example Zurich Instruments. But we also see companies that are, I think, closer to the application layer. Like I think Inflection is doing more on the algorithm side, if I'm not, or was it maybe Pascal? I'm not sure. I'm always getting confused as well. I have to look up these things. Sorry for that. And then there are some further resources down here. Okay, let's quickly also check out the Get Quantum Error Correction Ready part. So there's the Error Correction Explorer here. The Explorer integrates high accuracy software decoders and noise analysis tools into quantum error correction experiment workflows, benchmark the logical fidelity of your experiments and production devices, and analyze noise sources to improve logical fidelities for future experiments. Quantum Error Correction Explorer offers offline decoding capabilities that are complementary to Riverlane's real-time hardware decoders. So I think it sounds like this is kind of an analysis tool. You see that it's like it looks like a Python Jupyter notebook here, where you basically create those plots that are telling you something about, probably like, the errors that your system is making, right? Accumulating. Getting started with the Quantum Error Correction Explorer is quick and easy. All features from simulation to cutting-edge decoding are available through Jupyter Notebooks. That's what I said before. You can learn more about the Explorer's capabilities by accessing the documentation. Contact us for trial today. So this is, I think, not an open source software. There is a documentation here on how to use it, but it's not like somewhere out there in GitHub where you can just copy paste it. It's something that you would have to reach out to Riverlane to in order to be able to use it. And yeah, it comes with, I think, some text here, some explanation text, some code sections, and it also creates all of these relevant benchmarking plots, like for example this correlation matrix here. There's some more information here about introducing Riverlane's ambiguity clustering decoder. So that's the LDPC decoder. That is the proprietary technology that we've seen before. The decoder that's 25 times faster than the industry standard. Would be interesting to see how this is measured, but I guess that's here in the full paper. So the QLDPC codes can make do with far fewer physical qubits than the current leading quantum error correction code, the surface code. But we still need to be able to decode QLDPC codes in order to take advantage of this qubit reduction. That's where ambiguity clusters comes in. Read the full paper here. Our proprietary AC decoder is now available in the latest version of our analytics tool, QEC Explorer. Request a demo for more information, and then there's some images down here. Okay, we also quickly look at this part here, the QECI, meaning the quantum error correction interface, is being developed by Riverlane to provide a standard way to communicate communicating between the control system and the quantum error correction stack in any quantum computer. QECI facilitates efficient data transfer by defining the data format, runtime states, and parameters from communicating quantum error correction specific messages over a standard data connection. So now here we see again in the stack where this is basically sitting. It's sitting between the physical product that we've seen and the actual control system, the control electronics that is what is producing, for example, the signals that go down to the fridge. And then the quantum computing system doesn't necessarily need to be a cooled system, right? Could also be probably an ion trap. And then we see here on the other side of it, there's the data processing and routing, the data management part, and it's sitting basically in between here. So the benefits allows independent upgrades of the control system and the QEC stack. QECI defines the communication protocol, so it is easy to upgrade or replace the QEC stack or control systems without backward compatibility issues, provides long-term interoperability of the quantum error correction stack with your favorite solution by providing a common standard for communication. QECI enables the hardware to choose the best solution for their needs without being locked into one supplier. And then finally, it also says here, enables enables quantum computer makers to concentrate on scaling their physical and logical qubits. The next major breakthrough in quantum computing will be a machine that performs 1 million error-free quantum operations. QECI will meet the data transfer demands for the mega quantum operation machine and beyond. And then we see here the partners, Inflection, Qblocks, and Rigetti that seem to already use this software stack. And again, there's a way to reach out to them. I don't want to hop into the research and the news, but I quickly want to check out who is actually the company, who's Riverlane. So here it says, our story. Riverlane was founded in 2016 by Steve Brearley. Sorry if I pronounced that wrong. Senior researcher fellow in computational mathematics at the University of Cambridge. At that time, the majority view in the global quantum computing community was the useful quantum computing was more than 20 years away or might never happen. Steve's own research identified a quantum Moore's law whereby small-scale quantum computers are doubling in power every 2 years, meaning useful quantum computing at scale could be achievable within a decade. Armed with this evidence, the support of Cambridge University and intensive guidance from ARM co-founder Jamie Urquhart, amongst many others, he founded Riverlane from his kitchen table and has never looked back. So here we see the founder. Seems to be a very nice guy. Quick comment, because when I read this, I always have to think about it. I think there are many people that are talking about this analogon of Moore's law in the context of quantum. There's probably something to it. For example, there's also Google saying they call it the Nevin's law, called after Hartmut Nevin, who's the head of this department. And I've also seen other companies making that same claim. It's always a bit phrased in a bit different way. I think there's something to it. So when I started working on qubits in the lab, we had 2 qubits, and now, you have like 200s. So there's definitely some growth there. But I think on the other hand, it's also a bit more complex, right? Because it's not just enough to add another qubit, but in order to make this really useful, you have to make sure that it's well enough connected so that you could, for example, create a superposition state which goes across the whole system, right? And that's a little bit more difficult than just adding one more qubit, because if you don't make the whole system more accurate at the same time, you cannot really create this state by just adding more qubits. So adding a qubit is a challenge, because it means that you have to get more signal lines down to your cryostage, depending on what system you are using, or more ions in your ion trap. So there's a physical challenge to adding another qubit. But besides that, there is also, let's say, an information science challenge, because you can only really use this qubit if it can profit fully from its quantum properties, which is superposition and entanglement across the whole system. So only if it's like a fully connected qubit, or whatever you want to call it, that can be used in the full superposition. For me personally, I would count this as another qubit in the system. But that's just my personal opinion. Close bracket, we move on with the company. So about us, today Riverlane is over 100 strong, 100 people strong, with offices in Cambridge, UK, and Boston, US. The company's mission, to make quantum computing useful far sooner than previously imaginable, remains unchanged from day one. Building DeltaFlow, the quantum error correction stack, is how we achieve this. We partner with many of the world's leading quantum computing hardware companies, labs, and governments. We are backed by the University of Cambridge and leading technology VC, so venture capital firms. Here we see the management. Then I guess here's the board, so the board of directors. There are some featured experts here. And then there's the whole team down here. So these are all the 200 people that have been mentioned before. And then down here it says, if you relish technical challenges and want to help develop groundbreaking quantum software as part of our collaborative team, take a look at our vacancies, so the open positions. Which, if you like the company, you might want to consider doing. With that, I would like to finish today's video. I hope you liked it. If so, make sure to give it a thumbs up, and then also make sure to subscribe if you don't want to miss out on another one. And with that, see you in the next one. Bye bye.